In this program, we want to address the following question. How many critical points, inflection points, and extreme points does the function f have? Where we know that the function f is this function drawn below, and we know that f is continuous on the interval, open interval, -5 up to 3. And open, keep that in mind. So this is important, so to keep that in mind. So let's go ahead, and what we're going to do is we're going to walk around the graph. So we start at when x is equal to -5, we start up here, and then this is not going to be a critical point because -5 is not part of the domain of the function. Then we're going to move down here. Then we see that there is a horizontal tangent line. Horizontal tangent line here, right? So the derivative at this point would be equal to 0. So this is similar to the behavior of the function x to the third, whose derivative is 3x squared. And as you know, this function at 0 has a derivative equal to 0. However, 0 is not going to be a local extrema for the function x to the third. So that's very similar. So we found the first critical point. So let's keep moving along the curve. So we move down here, and then what do we see here? We see a cusp. So this must be another critical point. Why? Because the derivative does not exist at this point. All right, so we found the second critical point. Let's keep moving. We move up. We notice that the tangent line is getting steeper and steeper, and then we see that the tangent line here is vertical. That means that also at this point, the derivative does not exist. So we found another critical point. So let's keep moving. Let's keep moving along the curve. Everything is good, and then finally we touch this point here where again the tangent line is going to be horizontal. In this case we do have a local max, and then we go down up to x equals 3, and we see that this point, since it's not included, then we don't bother about it, right? 3 is not part of the domain. So how many critical points did we find? We found a total of 4 critical points. So let's now look at how many inflection points we have here. So there is the first inflection point here, right? The function is concave up, and then here it becomes concave down. And then we found another point here because the function becomes again concave up. So there is another inflection point, concave up. And then here there is another change. And then here the function is going to become concave down. So we found a total of 1, 2, and 3. Let me just use a pen here. We have 3 inflection points. So how about how many extrema do we have? Well, we have basically 1 extrema here and 1 extrema there. A local minimum and a local maximum. So two extreme points. All right, and then we can also additionally study the signs, so the derivatives, right? So for instance, the first derivative, right, was going to be the first derivative of my function would be negative all over here. The function is decreasing. So here gets to 0, but then it's still negative, the first derivative. And then after this point, the first derivative becomes positive until it gets equal to 0, and then it becomes negative, and the function is decreasing. So the function is decreasing, increasing, decreasing. How about the concavity? We have studied that before. So you can do similar problems to this one very easily, I hope. Good luck, everybody. Bye.